this problem, I'll just state the keyword, the pericyclic reaction. So this is defined as changes in bonding can be described by electrons moving in a concerted fashion within a closed loop. That's going to be very helpful to answer our questions here. So going back to A, draw a concerted mechanism for the conversion of 1 to 2. So from the top to bottom here. Okay, looking at that, I see the new chiral center here on the carbon, and the bottom hydroxide and the hydrogen is still retained. So chances are you have to do something about that double bond. So in other words, now that the pi bond can act as a nucleophilic center, that creates a new bond here, and then that's gonna break this oxygen to create the negative charge, and then this double bond can actually attack this carbon. You see that circular motion here, so that's what we observe, and then we'll have this structure. So this answers part A. And then to answer part B, it asks the conformational change from 1 to 1A. Okay, remember the conformational change is usually the change via single bond between the carbons and any other element. And looking at that, I see that this part is on the top on structure A, the 1, but we see the bottom. So in other words, I see the minus on the top here, but it's minus charges on the bottom. And then the carbon is on the top, but it's now on the bottom. So in other words, if I am to draw the symmetry along this line, and imagine you flip this around 180 degrees, and you want to get this. So this is 180 degrees rotation via this wedged carbon-oxygen bond. So I will specifically point out, I'm talking about this bond here, the green color. Okay, and part C, draw the concerted mechanism for the conversion of 1A to 3 and 4. So this is asking another the arrow curve mechanism, and seeing that, I see this become our leaving group, and also we have a double bond between, we have double bond here, talking about this one. Okay, so what I can do is, because this is a leaving group, we definitely gotta break this, but we're gonna form a ketone here. So I place the arrow from that bond to the carbon oxygen. Now the carbon has 5 pairs of electrons, and that's very not good. So this pi bond in the double bond is going to interact or act as a nucleophilic center to grab hydrogen around, and then this bond you see can form a double bond between this carbon and that carbon. Okay, because that bond was missed by pushing that to the carbon oxygen here. Now here's the carbocation, and to fill up that hole, that's why we put the electron pair to create a double bond to create the neutral, net neutral 0 formal charge on our ring here. So by having this arrow, we're gonna create this leaving group, double bond, and the top is retained, so everything is good.